Welcome. We're the Group 3 of the CoE119L/E02 section, and we're here to explain the applying int10h and file operations in sample program. This is the design of experiment. So, the objectives of this experiment is to implement the requirements to showcase creativity and knowledge on programming, and also to be able to implement a sample program that includes arithmetic operation and memory addressing and apply it in int10h and file operations. So we used string manipulation for the arithmetic instructions for the addition, subtraction, and multiplication. Then we used the int10h for the interrupts. For there are many use of the int10h here, but this is most commonly used in the cursor position and grinding files. And for the file handling operations, um, in this design, we use the group on int21h file handling operations in file processing to create a file.
So I'm going to demonstrate the second part of our program, which is the mul instruction. So this part is going to ask the user to input two numbers, and then it will take its product as an output. Um, so the first number, I'll choose 13, and then the second number is 3, so the output should be 39. So as you can see, the answer is correct. So for the third part of our program, um, this part is the file operations. The user will be asked to input a string, and then after typing enter, it will be saved in a text file which I will show you later. So I'll input my name. So it should be seen in outputs.txt. So as you can see, the output is here in the notepad, just like I've entered it.
And now we're going to proceed with our sample codes. First is the 4.247, which is the add sub tree. Now we're going to see the problem, and it states that it demonstrates a add, sub, int, dec, and neg instructions and shows how the CPU status flags are affected. Then as you can see, the initial values x, y, and z, 26, 30, 40. And when we enter this, it will see that the values were executed, although we cannot see the flags because we're on the DOS box. And the answer is 36, negative 36. And then we're going to proceed with the last part, which is the cursor position. In this problem, it simply states you can control the cursor of the position of the cursor just by typing the coordinates. For example, the character is a asterisk. The first input is 69, and the second input y position is 21. If you're wondering why it's from 6 to 24, because it may overlap this part of the program. As stated, y is from up to down, which is this. This counts as 1, 2, 3, 4, 5, and then you can type from here onwards. And the maximum from top to bottom is 21. Then we're going to enter, and then as you can see, the cursor position, the position of the character is placed here, which is 69 spaces from X and 21 spaces from right. And that summarizes our design of experiment, which is the in 21 and file handling. If you have any questions, you are you are you all are free to ask. Yes. Thank you.